Hi, and welcome to the Getting Started video of how you get started on with Hopper, which is a development environment similar to, say, Arduino or MicroPython for microcontrollers. It runs on Windows. It's for people who are familiar with the Visual Studio experience or familiar with semicolon and curly brace languages, specifically the more modern ones like C# and Java, but C or C++ as well. And it's got a full symbolic debugging experience over the same USB cable that you use to upload your program to your microcontroller. So let's get on with it. So what do we support? We support these Raspberry Pi Pico devices, so either the RP2040 or the RP2350 microcontroller in the various different flavors that exist out there, with or without Wi-Fi. There's a lot of information about Hopper on the YouTube channel, which is just bigger tigger. On this channel, there's a ton of videos, but there's some handy playlists here if you scroll down. At the top, there's an introduction video, which is quite long, and I'll update this as Hopper changes over time. This one's 8 months old. It's ready for an update, but it gives you the full overview, and it's a little long. This Getting Started video you're watching right now is supposed to be short. In the handy playlist, there's one about the Hopper language, a whole bunch of videos on the Hopper language. I've also made Hopper work on the 6502 microprocessor, 8-bit microprocessor. So there's a whole playlist on how you do that. And I've got my own board that you can build. I've got several people who've built this board, and they've got Hopper running on it. There's a bunch of getting started tutorials like this one. There's a playlist on Hopper on microcontrollers, for things that are specific to different microcontrollers. And then there's device support, which covers everything from displays to real-time clocks and how to get them working with Hopper. Anyway, best way to navigate the website, the YouTube channel is the search bar here. So search on keywords. I try to keyword the descriptions, and then you'll find what you're looking for. There are a lot of videos. Okay, let's get on with this one. Like I said, Hopper is a modern semicolon curly brace language. It's open source. There's a Hopper repo on GitHub. As part of the repo on GitHub, under releases, there'll be the latest release. And if you look at the releases, there's two files you should be interested in. The first one is hopper.zip, which I'll download right now. And we'll just save it to the desktop, shall we? So I'm just going to save that on my desktop. And then there's all these UF2 files. And I'm going to download all of them, put them in a folder, but you're going to only need to download one. And I'll explain which one in a second. So I'm going to pause the video while I go and download all of these and put them in a subfolder. Let's just do that. So, like I said, I downloaded the Hopper zip file to my desktop. And then I can extract it to my desktop just by drag and drop like that. And you can put this this Hopper folder tree that you're extracting, you can put anywhere on your Windows computer. Hopper only needs this folder. It puts everything in it. It's got the binaries in it, the debug stuff, all the source code to rebuild Hopper. There's about 200,000 lines of Hopper source code. So if you're interested in Hopper, and we can get rid of the zip file now. If you're interested in more than what this video is going to tell you, like what's happening behind the scene, there's also a Hopper internals playlist, which you can go look at. Okay, so under the bin folder, to run Hopper, all I do is run this executable. And the first time you run it, you're going to get a warning like this, because it wasn't really installed with an installer. But if you look on Run Anyway, it shows you that it's signed with a certificate by me, and you say Run Anyway, and that'll only happen once. And now it's in this folder tree. So let's go up to the root here. So if I do a dir here, this is the Hopper console. You can see we're in this folder tree, and Hopper can't escape beyond the root of this folder tree, and you can put it anywhere you like. Okay, as I was saying, I'm going to download all the UF2 files so that we can talk about the naming convention of the UF2 files. So what's a UF2 file? Well, I'll get back to you once I've downloaded them all here. So here I've downloaded all the UF2 files. And where did I get them from? Again, from the releases, all these UF2 files here. And like I said, you're only going to need one of them. But I'm going to talk about the naming convention. Now, what are these? Well, the same as with MicroPython, the way you initialize, the easiest way to get Hopper onto your microcontroller is to drag and drop one of these UF2 files on it. So the way that's done is you take your microcontroller and plug it in, but you do it while you're holding down the boot button. Let me show you what I mean. Right, so I plugged it in while the boot button was held down, and what that did is it launched another folder. So if you see it's drive E on my machine, it launched like it was a USB drive. And then the way you flash the firmware, similar to MicroPython, is you just drag it and drop it across. And I'll tell you in a second why I'm dragging and dropping this particular one across. There we go. And then if it's a success, it should vanish just like that. So it's as simple as that. We've now got our Hopper on our microcontroller. Okay, so now if I go back to this Hopper folder and I go to the bin folder, there's the exe that gave me that warning earlier. It shouldn't do it again. If I run it, it should just launch the. It should just. It's weird that I've got this screen distortion. Let's try that again. Don't know what that's about. That's better. Okay, so there's my Hopper shell, and let's make it full screen on the video. And yeah, it looks like I've already got Blink running on the device. But anyway, under the folder tree, there's a lot of source code. So there's a source code to the compiler, the debugger, all that. And then under that all, there's something called samples. So let's go to samples. And Hopper runs on the 6502, the RP2040 and RP2350 devices, but it also runs on Windows. So some of these samples are to run on Windows because obviously things like the compiler and debugger run on Windows and they're written in Hopper. But then there's a subfolder called MCU, microcontroller, and there's a bunch of samples under there, and we're going to edit the Blink sample. For simplicity, I'm going to get rid of the boards I'm not using. And I'm just going to, let's see what the options are here. It all looks good. Actually, I don't want to run the optimizer. So it's got menus up at the top. I'm going to not run the optimizer because I want the debugger to step on all the lines of code. And if it optimizes some of them away, it won't be obvious. You can click Save on Build so that when you save, and there's Build. And all these shortcut keys are very similar to Visual Studio. So, and if I F7 now to build, Visual Studio key, that at the top right changed from pink to green, meaning it was unsaved, now it's saved. And now if I press F5, it should upload it, F5 to run. If we look at the bottom of the screen, successfully uploaded blink.ihex, so it transfers the program across as an Intel hex file format. So I should have Blink on my machine, and now if I press, I've got two options here. I can either run with or without debugging. So if I run with debugging, that's F5 again. And and it's blinking again, as you can see. So here we go, blinking again. And it's outputting the number of seconds that the power's been on. And that's from this line here. So if I press Control C, this is where it's not the same as Arduino, because if you press Control C, it breaks in the debugger. So this gray bar in the debugger shows where we are, and at the bottom of the screen says waiting in the debugger. And if I execute, this is a really quick way of getting to your, built-in LED. You can set it to true or false, so, and you can read it as well. So what was it set to last? So since it's on, it must be true, and then I'm knotting that and setting it. So this should turn it off if I press F10. There we go, it's turned off. Now it's going to write seconds. So there should be quite a good break between 198 and now, since I've been talking for a while. So what you're looking at here, the green on black, is the serial console. which is this Reitlin here. It's a little bit like serial print in Arduino. And the gray bar went to the next line if I press F10 again. So F10 is the step instruction in Visual Studio, so it's the step instruction here. Delay is like delay in Arduino, and it alternates again. So as I go through here, that LED is going to blink on and off, right? So let's make it more interesting. If I get to the LED, and I press F11, which means step into. Actually, let's do what Reitlin first. So if I step into Reitlin, what's it going to step into? So it stepped into the 2-string, because it got the time in seconds and then stepped into the 2-string. So you can see some of Hopper is written in Hopper. And as I step down, I should get another variable here. So this is the watch window on the right, the stack. And Hopper initializes everything to a 0 value. So strings will be empty, Booleans will be false, numbers will be 0. And then it'll step through here and build that string. And you can see it building up in the debugger there on the right here, 269. And this is now 0. We can see this was an argument. It's in there, and it's 0, so it's going to go past that, and it's going to return it. There we go. We got our 269 back. So that's stepping in. Let's go step into the LED property. So LED property is actually written in Hopper as well, and you can see there's a unit called GPIO, and it's just the getter is just going to return the current state, which is a local variable, and we can see it's false right now if we look in the watch window. So F11, and now it goes to the setter, and we've inverted it, so the value argument set to the getter. This is very similar to how it's implemented in C#, setters and getters. So there's a Boolean property called LED, and it has a setter and a getter. Very similar to C#. And it sets the new state, and then it's doing the pin mode thing every single time, so that you didn't have to worry about setting the pin mode. You know, same as Arduino pin mode. And then there we go, and it's going to digital write, which means it should, if you look at the video, it should go on again now. There we go. Okay, so there you go. A short introduction to how the debugger works, and this green bar at the top means you're in the debugger, and there's the menu options for the debugger. You set breakpoints with F9, so I can put a breakpoint in here. Red, or turn it off, and it'll go until the breakpoint. There we go. Stops at the breakpoint. And then Alt F4 or just file exit to exit the debugger here, and I'm back in the editor. And the editor's got a blue bar at the top to show you where you are. There you go. So that's getting up and running on this device. And as promised, I'm going to mention one more thing. Which is why there's all those UF2 files and why I chose the one I did. So I left this for the end because you might not be that interested. But let's go and have a look at them. So here they are. Right, so I'm going to switch to showing you the videos again, showing you the devices. Right, so what do we got here? There's a Pi Pico, but this is the Pico 2. Right, and that, for example, is the original Pico W, and this is the Pico 2W. Right, the difference between these is that the original ones were the RP2040 microcontroller, and the new ones are the RP2350 microcontroller. So let's look at our list again. So if we look at our list, I'm actually just going to do this in the Hopper screen because it's bigger. So, and I can just go find them there. So CD bin UF2 and do a dir. Oops, didn't like them. Yes, that's an interesting thing about the Hopper file system. There's certain characters it doesn't allow in paths. Like I don't think it supports an underscore or a dash. I guess we're going to look at it on the screen instead. Right. Okay. So if we look at them included in the name, there's a 2040 or a 2350. So that's the generation of the Pi Pico, the Raspberry Pi chip. So that's very obvious, like which one you're going to use. So like you might be using this WebShare device. There, that's better. I rearranged the screen a bit so that we can see what's going on. So you might be using this WaveShare device. So that's a RP2040. You can see it right there in the name of the board, and typically they'll have the name of the board, the name of the microprocessor in the name, like the, tiny 2040 or whatever it is. So that's kind of handy. So you immediately know that you're only going to be looking at either the UF2 files with 2040 in their name, or with the newer ones, you might be looking at the ones with 2350 in their name. And if you use a magnifier, you can look inside the chip, the Raspberry Pi chip, and see what the name is as well. It might be on the back too, but if not, just you could look at the specs of your device too. What does this say? Nothing particularly useful in terms of which microcontroller it's using, but this one's a 2350 one. Okay, so that's the first differentiator, is which board, and it's the most important one. The next important differentiator is the W. So on several of these boards, I've got a W. So you can see here there's a W. And that's Wi-Fi. And unfortunately, Wi-Fi is not standard. So they use different Wi-Fi chips, these different boards. Thankfully, with the newer ones, it's a little more standard. But with the older ones, it wasn't. So I'll show you what I mean. Oh, before I do that, another difference with boards is form factor. So this is the Adafruit Feather form factor, for example, versus the Pi Pico form factor. And the ones from Challenger are also Adafruit Feather form factor, which matters if you're buying peripherals, or so that they slot onto the same form factor. Anyway, I'm going to just get rid of the ones that don't have Wi-Fi, so we can focus on the ones with Wi-Fi now. Okay, so these are the most common boards that have Wi-Fi on them. There's two types. There's the old ones, the RP2040 ones. Arduino makes one as well, the RP2040 Connect, whatever it's called, but it's not reliable. I've experimented with it and I really don't like it. And it uses even a different Wi-Fi chip to all of these. It uses an ESP one. Okay. These are the first two, the RP2040 Wi-Fi boards that I like. This one's from iLabs, called the Challenger board. They have different Wi-Fi chips, which means that you need to have two different UF2 files for them. Another thing with Wi-Fi is, let's have a look at that. Let's get it out the way a bit. You can see by the size, if I sort by size, all the Wi-Fi ones will be at the top because the Wi-Fi ones are a lot bigger. So the original Challenger board is the 2040 Challenger, which it's right at the bottom actually. It's got quite a small, it's the smallest one. So that's the original Challenger board. So it's a 2040 and it's got W and it's the Challenger board and it has the word Challenger on the back. Okay, that's that one out, done. Then we get the original Raspberry Pi Pico with Wi-Fi. So that'll be a 2040 board with a W, which is Wi-Fi. That's that one, right? And now these are all the 2350 boards. And the guys from Pimoroni have done a great job because they made theirs compatible with Pi Pico, which is unusual. Up to my experience is all the Wi-Fi chips from third parties have been not compatible with the Raspberry Pi one. So these two are compatible. So because of that, there is no Pimoroni UF2. You just simply use the regular default one, and that's why I've named it that way. So it's a 2350 with Wi-Fi. So those two are simple, trivial to do. And then I've got one for the new Challenger board, which is this one here. So this is the 2350 Challenger board. Okay, we're almost done. So we've discussed pretty much all of these, except for the NoLoads. So what is NoLoad? Well, it's possible for you to write a Hopper program, especially if it's new drivers or something. You could conceivably write a Hopper program that when you power up the board, because these programs remember what's on them. So which one did I do? I did the Pico 2, did I? Do that. So as I plug it in again, it should start blinking again because we put blink onto this, right? So when you power up, it immediately goes back into the program that you last loaded. Well, what if the program you last loaded really crashes badly, like to the point that you can't even reconnect it with the debugger? It's as close as we get to like bricking one of these boards. And one of the ways to solve that is to flash one of the NoLoads onto your microcontroller. And you only do this temporarily to unbrick it. So it doesn't have to have Wi-Fi or anything. So you just load the NoLoad onto it, like a 2040 or 2350. And then if you power cycle, it won't load the program that's on it, so that you can then load a new one on that doesn't fail on startup. That's what NoLoad's for. So if you get stuck not being able to connect to your board, you just flash it with NoLoad. Okay, and then there's one more thing that I haven't mentioned, and that's the RISC-V. So there's 3 RISC-V UF2s, and they're just variations on the same UF2 with the exact same name. So the RISC-V, so the 2350W RISC-V is just a variation on the 2350W, these two. And the difference is all the others use the ARM processors, and the new chip from Raspberry Pi also has 2 other cores. It has 2 RISC-V cores. So if you want to play with the RISC-V cores, you can just flash with the RISC-V versions. Haven't bothered doing a NoLoad one because you're only using NoLoad to unbrick. So you can use either one to unbrick it and then put the other one back again. Well, that was the longer part of the video, was describing the differences between these and which ones you need. But chances are you've got like a, tiny little RP2040 or a tiny little RP2350, and you'll use one of these two UF2s. If you don't have Wi-Fi and you've got a generic board, the chances are you'll use one of these two. Very good. Thank you for watching. Like I said, you should take a look at the I've got links in the description to the GitHub repo on and to where releases are on the GitHub repo for Hopper. And if you go to this channel and you look at the playlists, that's the next step, is where to go and look on the playlist for more information. If you enjoyed that, please press like. If you want more of my content, go ahead and subscribe. Thanks for watching.